In this video, I am going to simplify these radical expressions using the properties of radicals. Let's start off with problem A, which is cube root of 54. So our objective in simplifying this problem would be to get the largest factor, the largest cube, perfect cube from 54 we can, which turns out to be, by the way, 27, because 27 times 2 is 54 and 27 is a perfect cube because 3 times 3 is 9, then 9 times 3 is 27. Now by using the property nth root of AB is equal to nth root of A times nth root of B, I could rewrite it as cube root of 27 times cube root of 2. Now cube root of 27 I could further simplify it to 3 cube because 27 is 3 cube times cube root of 2. Now this cube and cube root are going to cancel out. That's going to just give me 3, then times cube root of 2, and that's all. We cannot simplify cube root of 2, so that would be our final answer. Now let's work on the next problem, which is B. That's very similar to this one as well. Square root of 300. Since it's a square root, we want to factor out the largest perfect square possible from 300, which, by the way, you probably already know is 100, because 100 times 3 is 300 and 100 is a perfect square because 10 square is 100. So we could again use this formula and simplify it to square root of 100 times square root of 3, but square root of 100 is 10 and square root of 3 is square root of 3. We can simplify it any further. So that's going to be our answer for part B. Now let's do it for part C. For part C, we have cube root of 625 divided by 16, which, by the way, I could simplify further to following: cube root of 625 divided by cube root of 16. The formula that I have used here is this: nth root of A over B is equal to nth root of A divided by nth root of B, given that the denominator B is not equal to 0. In our particular example, this n value is 3. So using this formula, I have broken this down into 2. Now I could simplify it further. Let's do the denominator, which kind of is easy. So cube root of 16, what is the perfect cube that I could factor out from 16? As it turns out that it's 8, because 8 is 2 times 2 times 2. Then 8 times 2 is 16. And similarly on the numerator, 125 times 6, by the way, is 625, and 125 is a perfect cube because 5 times 5 is 25 and 25 times 5 is 125. So I could go ahead and simplify it further. Now this time, to simplify, I'm going to use this formula: nth root of AB is equal to nth root of A times nth root of B. So it's going to be cube root of 125, but 125 is 5 cube, then cube root of 6. Then in the bottom, I have cube root of 8, but 8 is 2 cube, times cube root of 2. Now if I simplify it further, this cube and cube root are going to cancel out. That's going to give me 5. Now cube root of 6, I could write it as cube root of 2 times cube root of 3. Why did I do that? Because I noticed that there is a cube root of 2 in the bottom, so that I can cancel it out. 2 times 3 is 6, as we have, and I have again used this formula. Divided by this cube and cube root cancel out, that gives me 2 times this cube root of 2, cube root of 2. Now this and this are going to cancel out. That's going to give me in the denominator 2, in the numerator 5 times cube root of 3, and that is your answer for the third part. I hope that this discussion was helpful. Thank you very much.